Hello, I'm Tyson Hamilton, an engineering manager at Snowflake, and I'm excited to be presenting telemetry to you today. I've been an engineering manager at Snowflake for a year now, building a new product and a new team focused on telemetry. Before joining Snowflake, I was at Google for 5 years, working on Dataflow, MapReduce, and Flume, which are distributed systems for data processing. And I spent a lot of time debugging distributed systems, focused on data, and I felt a lot of the pain with observability when you lacked it. So at Snowflake, we're looking to change things and bring new solutions to old problems in the telemetry space. This presentation focuses on how we instrumented a Snowflake native connector to improve observability. I'll briefly walk through the native application framework used by our engineers to develop the connector, move on to the native telemetry APIs and pipeline used to instrument the connector, and then explain how we used Snowflake Alerts to automate action on the telemetry data. The inspiration for this presentation came from our experience developing a native connector, but the driving example uses lower-level primitives that the native application developers interact with. This will allow me to focus more on the telemetry-related technologies, since they can be used in numerous core Snowflake functionalities, including native applications and connectors. The telemetry signals we used are logs and trace events. Metrics will be ready soon, but we're not going to cover them in this talk. Logs are simply unstructured text messages with some metadata that describes an event in the application. They're the ubiquitous telemetry signal used by all. You can see the classic "Hello World" message in the method call. Trace events are a structured payload that also have some default metadata that describes an event in the application. But they also provide a mechanism for adding your own metadata as key value pairs. The structured nature of events makes them ideal for data analysis. Metrics are periodic measurements of longer running processes or systems at runtime. They're optimized for aggregation. Counters and gauges are good examples of a metric, but these aren't supported yet. Let's develop a bit of domain knowledge for connectors and native applications before going too much further. A connector helps you ingest data into Snowflake from an external source or service. It simplifies the process by doing all the heavy lifting. Native connectors execute within a customer's account and could be developed by Snowflake or third parties. We are building native connectors using the native application framework. This is one example of Snowflake on Snowflake that we'll look at in this presentation. To understand some of the difficulties we encountered while developing connectors, we need to understand the basics of a data application. The native application framework is a rich and powerful concept that allows building and sharing data applications. A data application has a provider and a consumer. The provider owns and develops the application. The consumer uses the application by installing it and interacting with it. Typically, the relationship between provider and consumer is one to many. One data application provider to many consumers of that application. The data application is installed in the consumer's account. It also executes using the consumer's resources. Application consumers interact with it to act on their data, without having any data leave their account, and without giving access to their data to application providers. Data applications write telemetry into a table in the consumer's account. Consumers can use this telemetry to collaborate with providers while debugging any issues that come up when the application is running. There may also be valuable information in the telemetry data like audit logs or statistics on operations or even failures that the consumer can resolve themselves. It's also critical that the provider has visibility into the telemetry generated from these applications. For example, when developing the application, logs will be helpful for debugging. When the application is installed in the consumer's account, the provider may also want to have visibility into telemetry for debugging. The action of the consumer sharing telemetry data with the provider we call event sharing. Providers can only see the consumer events when the consumer opts into sharing them. This gives the consumer an opportunity to audit the contents before sharing it with the provider. This functionality is all available today, and it's an important step in our roadmap for enabling developers, both internal and external. And that's because Snowflake is growing the programmatic surface area that developers can interact with. In addition to SQL, there are stored procedures in Snowflake scripting and JavaScript. And if you use Snowpark, you can develop stored procedures in Java, Python, and Scala as well. Snowpark also introduced user-defined functions and user-defined table functions to developers. The native application framework takes that even further by enabling developers to create full-blown data applications and share or monetize them on the marketplace. The core functionalities native applications use that are relevant to this talk include stored procedures, UDFs, and UDTFs. For example, when a consumer installs a native application, an installer stored procedure is called. That installer is written in SnowScript or JavaScript, and it can be instrumented for improved observability. All of this code executes within Snowflake's runtime on warehouses, and in some cases like Snowpark UDFs, inside sandbox containers, where visibility into the underlying system where logs and events are written is not possible, and outbound network connectivity is limited. Under these constraints, it's pretty clear that we need a solution to get telemetry out of the runtime environments. And to do this, we introduced the telemetry pipeline. It is responsible for the entire flow of telemetry data, starting with the APIs for generating telemetry signals, to automatically ingesting the telemetry data using Snowpipe, and finally providing users with an event table for analyzing the telemetry. We use the pipeline internally for visibility into our own UDFs, UDTFs, stored procedures, and of course data applications like native connectors that are built on the native application framework. The pipeline uses OpenTelemetry, which is a cloud-native computing foundation incubating project. OpenTelemetry is a collection of tools, APIs, and SDKs for working with telemetry. If you're familiar with the project, you'll recognize the data model and concepts when using Snowflake's telemetry pipeline. The telemetry APIs are supported for UDFs, UDTFs, stored procedures across many languages. These are the primitives that can be used on their own when writing queries, but they're also used to build native applications. Let's take a look at an example of a JavaScript stored procedure. Here we are creating a procedure called positive sentiment that accepts a string parameter and returns a string representing the sentiment of the input. This is a very happy stored procedure since it always returns a positive sentiment. The add event method is evoked to create an event named call with some attributes that describe the input text length. The key is text length, and the value is simply the length property of the text parameter. This is all that's required to create an event in a stored procedure. This would generate an event per row processed by this stored procedure if it were enabled, which could be a lot of events, so make sure you exercise caution when using these APIs. You can control the trace level by altering the parameter at various scopes. In this example, the trace level for the procedure is set to always, which means the events will always be emitted. Check out the docs for other trace levels. One tip from our engineering experience is that using exception handling to instrument your application is very helpful. No surprise. In this procedure, a log line is emitted with the fatal log level when an exception is caught. There is a parameter to control log level as well. In this Python UDF, we import a telemetry module to gain access to the necessary telemetry APIs for generating telemetry data. It has a similar feel to the JavaScript example where we call an addEvent method with a name and some attributes. Similarly, when handling the exception, we log a message. In this example, we use the Python standard logging modules And in Java, you can use the SLF for J for logging to integrate with the pipeline. After generating the telemetry data using the APIs we just looked at, they are automatically ingested into Snowflake using Snowpipe. That's the second instance of Snowflake on Snowflake that we'll encounter in this presentation. You don't have to do anything for ingestion. It's all handled automatically. The telemetry data lands in an event table. This is a managed table that has a predefined set of columns. There is only one active event table per account. Here's an example of creating an event table. First, we create a database, then a schema, and finally the event table called events. We then set the newly created events table to the active event table for this account. You can then grant log level and trace level privileges to an admin role. Here, we use the central telemetry admin role as an example. Afterwards, you can start to configure the log and trace levels at different scopes. Here, we set the log level parameter on the DB1 database to error and on the F1 function to warn. Some things to note: you can also set log and trace levels at the session scope. Be careful when setting these log levels because logging or creating trace events per UDF record could be a lot of logs. Let's take a break from looking at slides and check out a live example in Snowflake. This example looks a lot like one of the slides that we've already seen in the presentation earlier. We're going to be creating a procedure called positive sentiment. This is our happy procedure that we used before. I'm going to use the account admin role, select my warehouse, the database and schema that I've already created, and then I'll create this procedure positive sentiment. In the procedure, you can see that it takes a text string as the parameter. It returns a string, which represents our sentiment. The language is JavaScript, and I've written it inline here. You can see there's an add event method being called. This is the telemetry API we're calling here to create an event named call that simply has the attributes for the text length, which are the input parameter. After that, we do a log message and return positive sentiment because everything's positive to this stored procedure. If there were an exception or error, it would enter this catch block and log a fatal message, but I don't expect we'll hit that here. So let's create that. We'll set the log level and trace level below. And we'll call this method. Let's take a look at a few columns from the event table. You'll see a bunch that you expect for telemetry, like timestamp and event type, which in our example will be span or log. Then you'll see Snowflake-specific ones like query ID, session ID, warehouse name, database name, schemas. Source name will contain our method name here, our stored procedure name, positive sentiment. It'll contain the whole signature. We'll see that. And some more standard telemetry ones that you'd expect, like log level and the event message. So what did this return? I've selected a few columns from this table so we can take a look at their contents. Timestamp. So the log level is as we'd expect for this method or this procedure called positive sentiment. It's set to info. We have one log and one span. The source name is the whole stored procedure signature. And the event messages are, for a log, just the message that we set. For an event, it's a bit more interesting, and it looks just like OpenTelemetry's event messages. And it has a number of attributes, like the end time of the span, our attributes that we set, custom ones that we set ourselves as the developer, and some automatic ones that Snowflake introduces, like the count that this stored procedure was called. And down below, the trace ID for distributed tracing. And that's an example of the span that we created from this stored procedure. This was a pretty basic example of using the telemetry APIs inside of a stored procedure in the Snowflake UI. Let's get back to the slides. Now that you've seen the whole telemetry pipeline, let's go back to the native application for a minute. When the data application runs, it is running in the consumer account and generating telemetry data that is being ingested into the active event table in the consumer account. For a provider to see these telemetry signals, the consumer must explicitly enable event sharing. This ensures that the customers have the ability to audit the telemetry data before it is shared with the provider. Once the provider enables event sharing, new telemetry data will be ingested into both the consumer and provider event tables. Now the provider has the ability to debug the application that is running in the consumer's account. The provider only sees the data that is being shared from this data application, nothing else. We can also take automated actions on this telemetry data in Snowflake with alerts. In fact, you can create alerts using any data in Snowflake now with Snowflake Alert. I'm really excited about this feature since it's been a big request from customers. We're using this internally, paired with the send email stored procedure to send alerts to our team. A Snowflake alert is a simple but powerful abstraction that allows users to automate action on data conditions. For example, a user could create an alert to send an email notification to a system administrator when a query is taking longer than 5 minutes to complete, or when a table hasn't been updated by 9 a.m. for your report, or if there's an increase in errors in the event table in the last few minutes of the current hour. Alerts have a condition that is evaluated on a schedule. The condition is a select, show, or call statement that returns 0 or more rows. If 1 or more rows is returned, the action is executed. The action is a SQL statement. The example alert we're creating here sends an email if our report table hasn't been updated in the last 45 minutes. It's scheduled to run every 15 minutes. You can also use a cron syntax here. The condition is inside the if exists clause. It returns a row when the table hasn't been updated in the last 45 minutes by querying the information schema. If a row is returned when evaluating the alert, the action is executed. The action is after the then keyword. And in this example, it calls a stored procedure to send an email. So what are some of the lessons we learned? Without telemetry, it's really difficult to understand application behavior. We struggled at first, and that's why we created this pipeline, the telemetry pipeline, so that we could get visibility into the work that we were doing. It's important to wrap all code with exception handling to instrument errors, and you can rethrow if you want, but the important part is to give yourself an opportunity to collect the telemetry and have it ingested into Snowflake for analysis later. It's a good idea to generate more telemetry than you think you'll need up front. It's easy and inexpensive, but it's important to remember that it's not free. You can use events to introduce payload structure for easier analytical querying. The structure makes it very easy to filter out data, so use it to your advantage. So in summary, logs, events, and soon metrics are available for UDFs, UDTFs, and stored procedures to support application developers. All of the telemetry signals are automatically ingested into an event table. You can use alerts to provide a scheduled if this, then that workflow. And I think the cool thing here is that Snowflake uses all of these tools internally. So we're going to continue to improve them, and we look forward to hearing your feedback. Thanks for watching, everyone. Make sure to like and subscribe for more special content. And if you want to find out more information, check out developers.snowflake.com.
Almost 10,000 miles away from Africa lies an area known as the Silicon Valley. Known for its Patagonia-wearing inhabitants, indigenous scooters, wild robots, and unaffordable housing. Here, we find a lone python that has traveled all its way in search of colder climates, better opportunity, and stock options. The python can grow to be over 30 feet in length and concatenate string literals together. These non-venomous predators have different diets depending on their size, where most prefer rodents, lizards, and small birds. The one you see here prefers data. Where is this python's journey taking us, you may wonder? Well, to Snowflake, of course. It's in search of their snowpark to call home after a long voyage across the world. Python for Snowflake has arrived.